Okay, next is the shift of index of summation. So before we go over to the method of finding the solution by the power theory, we got to learn how to do the shift of index of summation. We will just do the assumption of y is equal to summation of an x to the power n equal to 0 to infinity. So when we do the first derivative of it, we would get an times n times x to the power n minus 1, and when we do the second derivative, we would get n times n minus 1 times x to the power of n minus 2. Now, for this term, the second term, and the third term, you would see that the power of x is just going down by 1. So, if we want to write it in the terms of x to the power n, what we can do is just that we take a look at the first term first. The second term first. An times x to the power n minus 1. If we want to make the term of x to the power of n minus 1 become x to the power n, the way that we can do is just that by doing the shift of index of summation. So, in order to get n minus 1 become n, you got to replace this n with n plus 1. So, when you replace it with n plus 1, every term in the summation got to change into n plus 1. Now, if you take a look at this one, when you replace n with n plus 1 there, you would see that if you put n plus 1 here, you would get n plus 1 equal to 0 and your n starting from minus 1, which doesn't make sense. N is supposed to be a positive number, so it's got to start from 0 until infinity. So, in order to avoid of getting n is equal to negative number, what we should do is just that replace n is equal to 0 in each term here first, okay, and then do starting n from 1 until infinity. So if you put n equal to 0 there, you would get 0, right? So this term you would get 0 plus summation n is equal to 1 until infinity, a n times x to the power n minus 1. So the way that you write down this one and this one have the same meaning, because at n equal to 0, the first term is equal to 0. Okay. Now, we are going to do shift of this one. And then we replace n is equal to n plus 1 there. You would get n plus 1 equal to 1 there. And this n, you replace it with n plus 1. And an is become an plus 1. And x to the power of n minus 1 become x to the power of n plus 1 minus 1. By doing this, we would get summation of n starting from 0 to infinity of n plus 1 times an plus 1 times x to the power n. And then now we got the same power of x. And for the terms of this x to the power of n minus 2, this one I did already for you the last problem. If you want this to become n x to the power n, you got to replace this one by n plus 2. So if you put n plus 2 here, your n would start from minus 2, which doesn't make sense. So what we are going to do is just that we put n to here until n is equal to 2. So you plug n is equal to 0 we got 0. We put n is equal to 1, we got 0. And now the rest of the term is n starting from 2 until infinity. That wouldn't change anything because the meanings of this and that is the same. Okay. And then if you want to do shape of this term, you just put n equal to n plus 2 there. So you would get n starting from 0 to infinity of an plus 2 times n plus 2 times n plus 2 minus 1, which is equal to n plus 1 times x to the power n. Okay, now what if we have another term like this? Summation from n equal to 1 until infinity of an x to the power of n plus 2. We want to make this n, x to the power n plus 2, become x to the power n. Then we have to replace n equal to 1. If we want this term to be x to the power n, we've got to replace n with n minus 2, right? N minus 2. So then we would get n minus 2 equal to 1. Then what our an would be an minus 2 x to the power n minus 2 plus 2. So then we would get summation n starting from 3 to infinity of an minus 2x to the power n. This is called the shift of index of summation. Now let's take a look at another example on finding the solution of differential equation where we have the coefficients as a variable. The example